Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve first two questions of a paper, and these two questions belong to paper 9709/42 for the session October November 24. Let's read the first question. It says the velocity of a particle moving in a straight line at time t seconds after leaving a fixed point O is v meter per second. The diagram shows a velocity time graph which models the motion of the particle from t equal to 0 to t equal to uppercase T. The graph consists of four straight line segments. The particle accelerates from rest to a speed of v meter per second over a period of 4 seconds and then decelerates at 5 over 3 meter per second square to instantaneous rest over a period of 6 seconds. The particle then travels back towards O, reaching a maximum speed of 3 meter per second before coming to rest at time t equal to uppercase T. Well, it's a velocity time graph. From this velocity time graph, we can find out the acceleration. That means we will apply the simple concept of Schubert formula, and we know that acceleration is obtained applying v equal to u plus at. So we are going to apply the formula, and we are taking the second part of the first phase, okay, when it was decelerating until it is at rest. So what is the formula we are going to apply? We know that the formula is v is equal to u plus at. So v is equal to, we know v equal to u plus at, okay, and our final velocity for the shown direction, final velocity was 0, okay, and initial velocity was v. It started from the velocity of v, and as it is decelerating, look at this acceleration, I mean direction is negative. As it is decelerating, so the symbol will be negative. And acceleration was what? Acceleration, it was decelerating at the rate of 5 over 3 meter per second. So 5 over 3 meter per second. And now it's time. What is the time? In time is this one, 10 minus 4. 10 minus 4 means 6 seconds. Well, after that we are going to get v is equal to 3 twos are 6. It may be the last of all steps. So let us write hence symbol. Hence velocity is equal to, if we divide this 6 by 3, it is going to, or 5 6 are 30, 30 over 3 means 10. So velocity v is equal to 10 meter per second square, or only 10 is sufficient because the dimension has been given. That means maximum velocity when it was moving upward, I mean moving onward, then the highest velocity, maximum velocity was 10 meter per second. Let's see what the immediate next question says. It says, given that the total distance traveled by the particle from t equal to 0 to t equal to uppercase t is 68 meters. So total distance is equal to, total distance is given 68 meter. Distance total distance is equal to 68 meters. Now if we form an equation, total distance means when the particle was moving onward and moving backward, total distance is the area of that region. So first, when the particle was moving onward, this was the region, and when the particle was moving backward to O, that was the region. So sum of these two areas or regions is equal to the total distance. So let's find the area of the triangle when it was moving onward. We know area is equal to half of base. Let us see how much was the base. Base for the first triangle when the particle was moving onward, base was 0 until 10, so it is 10. 10 into height. Height is v meter per second, and we have obtained v is equal to 10. So this is also 10. Plus the area of the other triangle, that means when the particle was moving backward. So half into height or base. Base is 10 until t. That means t minus 10 is the time spent. T minus 10 base, and height is already given. It is 3 meter per second. So height is 3 equal to right side is 68. Well, I think you have understood that. That means area is found always the traveled area. Area is the total distance. Distance is equal to traveled area. That means the area which has been traveled by the particle or the car. So as there are two different areas, that's why we have added up these two areas to find the total distance. Let's simplify this. If we simplify, we are going to get, yes, so 10 tens are 100, 100 over 2 means it is 50. So 50 plus, here if we divide this 3 by, so 3t, it is 3t over 2, 3t over 2 minus, it is going to be 30 over 2 means 15 equal to 60. Well, so 50 minus 15 means 35. From 60, if we subtract 35, it is going to be 25. No, it's not 60, it is actually 68. So if we subtract 35 from 68, it is going to be 3t over 2. If we subtract 35 from 68, it is 33. 33. Or it may be the last step, or let us write, or t is equal to 33 into 2 over 3. Hence our t is going to be, t is equal to what? 3 11s are 33, so 3 11, so 11 is 22, so it is nothing but 22 seconds. It is going to be 22. So the final result is 22 seconds. That means when the particle came back to the origin or the initial point, it took 22 seconds. That's all about the first two solutions. Let's move on to the immediate next question. The immediate next question says, a block of mass 20 kg is held at rest at the top of a plane inclined at 30 degree to the horizontal. The block is projected with speed 5 meter per second down a line of greatest slope of the plane. There is a resistance force acting on the block. As the block moves 2 meters down the plane from its point of projection, the work done against this resistance force is 50 joule. Find the speed of the block when it has moved 2 meters down the plane. Well, let us find the clue word of this question. The clue word of this question is actually, look at this, the work done against this resistance force is 50 joule. Means indirectly they suggested us to apply the concept of work energy equation. And what are the components of work energy equation? The components of work energy equations are height as well as, that means difference between final and initial heights, as well as difference between the final and initial velocities. Let us see whether we do have all of these components or not. If we look at this, they have told the plane was inclined at 30 degrees. So it is just like this. This is 30 degree. Okay, 30 degree. And if we want to find the height, this is our height. This is our height. Okay, and the block was moving downward for 2 meters. So the length of the plane is 2 meters. So what is our height? Our height is equal to, if we write here height, so our height is equal to what? 2 meters to sine 30 degree. 2 sine 30 degree equal to sine 30 is half. 2 over 2 means it is 1 meters. Okay, 1 meter was the difference between the final and initial height. Okay, now we are going to apply the concept, because they have already disclosed that we should apply the concept of work energy equation. What is the work energy equation? Work energy equation is work done by driving force minus work done by resistance force is equal to change in GPE, gravitational potential energy, plus change in kinetic energy. Okay, then about driving force, look at this. Is there any driving force or not? Actually, driving force indicate that any external force, no external force has been acting on the block, because it was, look at it, the block was projected with, it was projection. That means no external force is acting on this block. That's why there is no driving force, hence work is zero. Then resistance force, but the plane was not smooth at all, it was rough. That's why there was a constant resistance force, due to what? The work done against this resistance to motion is 50 joules. So it is 50 equal to change in GP, you know, mgh, plus change in kinetic energy is half mv square. Mv square means difference between the initial and final velocities. Well, on the left side it is going to be negative 50. On the right side, mass of the block is 20 kg, it is 20. So we are going to write 20, and acceleration due to gravity is 10. Now height. Okay, look at this. Initial height was here and final height is, suppose this is the ground. So initial height was more than the final height. That means if we subtract the initial height from final height, it will be negative. And how much was the initial height? Initial height was, let us see how much was the final height. Initial height was, look at this, initial height was 1 meter. We have already found here initial height was 1 meter, final height was 0. So it is just 0 minus 1 means 1. Okay, so it is going to be 1, plus half of mass of the block is 20, and final velocity again, v square means difference between the final and initial velocity. Final velocity is to be obtained and initial velocity is given. How much was the initial velocity? Initial velocity was 5 meter per second. So minus 5 square. So please don't get confused in applying the work energy equation. It is height. H indicates not height, it's actually difference between the final and initial heights. If initial height is higher or more than the final height, then it must be negative. Well, after that it is going to be negative 50 equal to, it is going to be negative 200, plus it is going to be 10 v square, 10 v square minus 5 square means 250. I mean 25 tens are 250. Well, Now if we write everything on the left side, it is going to be, on the right side there was 450. From 450, if we subtract 50, it is going to be 400. Or 400 is equal to 10 v square. By 10, if we dissolve both parts, it is going to be 40. So v is equal to actually square root over 40. And we know square root over 40 is 6.31 something. So it's, if we round it up to three significant figures, it is 6.32 meter per second. 32 meter per second. That's all about the final answer. And this is one of the most common questions in mechanics, and it's nothing but application of work energy equation. In work energy equation, only the points which we should remember, that height doesn't mean height. Height is actually difference between the final and initial heights. So is the velocity. Velocity is not velocity, it is actually difference between the final and initial velocities. And I understand that you have already got the points I have described. So thank you all for being with me, and inshallah in the next video we will talk with each other. Fi amanillah.